Good morning. This is Dwarkanath S.K., Assistant Professor, Department of AAA, SJBIT, Bangalore. Welcome to today's video on electricity network in a smart grid, which comes under the course called Smart Grid for the target audience of final year engineering students. So let us go into today's topic of discussion. So what is smart grid all about? So let us go into detail about it. What is the basic generation capacity as of now in India? So what is meant by the word smart grid? So the electrical power system delivery has its own cited as one of the greatest and the complex machine ever built across. So which consists of what? Wires, cables, transformers, towers, circuit breakers, all together fashioned fine. So actually this power system delivery system is almost entirely a mechanical system which consisting of the sensor, minimal electronic usage and almost no electronic components. So in the last 25 years, if you see the history, industries in the Western world, they have modernized themselves with the use of sensors, communication and computational abilities. For these industries, there is enormous improvement in productivity, efficiency, quality of the product, services and environmental performance. So there's a smart grid which is a use of sensors, communication, computational abilities and control in some form to enhance the overall functionality of the electric power system delivery. So this is one of the major things. So major key 5 aspects of smart grid which involves first one is the power system enhancement module, next one is the communication and standard module, and then the computational intelligence is required, next impacting on the environmental and the economics, and finally it has to be tested on the test beds. These are the major 5 key aspects of smart grid environment. So if you see the background aspect of it, so an electrical grid which is a network which is synchronization of power providers and that of the consumers which are connected by transmission and distribution lines, and it is operated by one or more control centers. If you see the red in color, which is called as the generation part of it, blue is called as the transmission part of it, green is the distribution side part of it, and black are the so-called customers. Okay, so rating wise you can see starts from 33 kV as per the requirement of the customer, which is tapped from sub-transmission site, and then the primary customer being 11 kV to 66 kV, and secondary customers being around 400 volts to 220 to 30 volts. So from the generation point of view, so electrical grid components which can be categorized into generation, transmission, distribution and the consumers part. So under generation we are having thermal, hydro, nuclear, now renewable energy sources have come into picture. So under transmission we have 2 cases, one is HVAC line and HVDC line, and in the distribution side we are having AC and DC, and the consumers can be categorized into industrial, commercial, domestic. So these are the various classifications of the consumers, we call it. So moving on to the definition part, what do you mean by how it got evolved? So from the evolution of the Indian national grid early 60s, this grid management on the regional basis have been started. So state grids were interconnected to form the regional grids. So India had demarcated into 5 main regions like northern region, eastern region, western region, northwestern region and the southern region. So in the year around 1990-1991 October, northeastern region and the eastern grids, they have been interconnected. In the year March 2003, western region and eastern region and northeastern region, they all were interconnected. In the period of August 2006, north and eastern grids were interconnected. Thereby 4 regional grids, northeastern, western, northeastern grids, all are synchronously connected, forming central grid operating at one frequency. In the year 2013, 31st of December, certain regions was connected to the central grid in synchronization with the transmission of 765 kV Raichur-Solapur transmission line, thereby achieving one nation, one frequency, one grid concept. So the key aspect as of now during the year 1617, the population was around that figure much. Total area is this, and energy consumption is around that much, and energy generation capacity is around 326 gigawattage. For network losses is in the range of 22.7%. So installed capacity as of now is around 326.8 gigawatts. This is as per the data of 1617. Among them, coal being the major of 194, renewable around 57. Now we have achieved the target of 100 gigawatts. Hydro is around 45, nuclear around 6.78, diesel around 0.83, gas is around 25.32 gigawattage. So what are the major factors which affect the performance of this smart grid, existing grid? So increase in the demand of the electricity, supply shortfall of the electricity, need of reducing the losses, peak demand management, and then integration of renewable energy generation systems, and then solution to global warming, effective use of electric vehicles, better customer satisfaction, overcoming the difficulties in the meter reading, poor efficiencies of the conventional power generation systems, potential of technological advancements, and new business opportunities. These are the major factors which is affecting the performance of the existing grid, conventional grid we call it. So what makes the grid smart? So the digital technology that allows for the two-way communication between the utility and its customers, utility meaning service provider, and the sensing along the transmission line is what makes the grid smart. So customer perspective, if you see, if you're already managing activities such as the personal banking from your home computer, image managing your electricity in a similar way, so customer will no longer have to wait for monthly statement to know how much electricity he has used. With a smarter grid, he can have a clear and timely picture of it. We call it as smart meters. This can able to how much electricity of is used, so when it is in usage and its cost. Combined with the real-time pricing, this allows you to save the money by using the less power when electricity is most expensive. So smart grid has the potential to help you save money by helping you to manage your electricity use and choose the best time to purchase electricity, and you can save them by more by generating your own power. Right side you can see the markets, operations, service provider, the bulk generation part, transmission part, distribution part, and the customer. All are interlinked among themselves. So what are the duties of the smart grid? It has to be more efficient transmission of electricity, quicker restoration and electricity after power disturbances, reduced operation and management cost for the utilities, and ultimately lower power cost for the consumers, reduced peak demand which will also help lower the electricity rates, increased integration of large-scale renewables energy systems, so better integration of customer owner power generation system, including the renewable energy systems, and improved security. Hope you guys have enjoyed today's topic of discussion on these subtopics. Just a second. So any queries, any doubts with respect to the topic? So with the today's topic of discussion, you can write down to my email ID. So that is varkanath@savat.edu.in. So you can subscribe to our department channel for latest updation on the videos. So thanks for watching today's video. Hope we will meet you in the next topic of discussion on the smart grids. Thank you, one and all.